Here is a word problem that we are going to solve using the law of sines. We have that a tree leans away from the sun at an angle of 5 degrees from the vertical. The tree casts a shadow 30 meters in length when the angle of elevation of the sun is 42 degrees. Find the height of the tree. Drawing a diagram for these types of problems will greatly increase your success at finding the correct solution. So let's walk through what the diagram will look like. So we have a tree leaning away from the sun. Let us assume the sun is over here to the left, and the tree is over here, and it is leaning away from the sun at an angle of 5 degrees from the vertical. So the vertical is a straight vertical line. So if the tree is leaning away from the sun, it's leaning here to the right a little. Not a lot though, just 5 degrees from the vertical. And we're given that the tree casts a shadow 30 meters in length. So from the base of the tree, horizontally to the right, 30 meters. Is how far the tree casts a shadow when the angle of elevation of the sun is 42 degrees. So that tells us that the angle from the horizontal to the line that goes through the very top of the tree, this angle is 42 degrees. And we want to find the height of the tree. So we want to find the side across from this angle of 42 degrees, which will give us the height of the tree. It will be helpful if we determine all the angles of the triangle. So if you look at your diagram again, we have the vertical and the tree leaning 5 degrees just to the right of vertical. And so we know that this vertical line makes a 90-degree angle with the horizontal line. Then this 5 degrees plus the degree from the tree to the horizontal must equal 90. So the adjacent angle from the tree to the horizontal must be 85 degrees. And we're given that this angle over here, the angle of elevation of the sun, is 42 degrees. So if we subtract 85 degrees and 42 degrees from 180 degrees, we can find this angle of our triangle made from the tip of the tree and this line from the horizontal to the tip of the tree. We find that angle to be 53 degrees. So, in the diagram, again, we have our triangle made up of tree, horizontal line, and this line from the end of the shadow to the end of the tree. If we let this angle be alpha, which is 42 degrees, then the side A is the height of the tree. And if we let beta be this angle at the top of the triangle, which we found to be 53 degrees, then B, the side across from it, will be the length of the shadow here on the horizontal, which is 30 meters. So now that we have an angle and a side across from it and another angle and the side across from it, we can use the law of sines to find the length of the side A. Remember, we want to set up the law of sines as the sine of an angle in the same ratio with the length of its opposite side. So then if we solve for a, we have that a equals b times sine alpha divided by sine beta. And substituting the values we have for b, alpha, and beta, we find that a is about 25.1. And then to recall what a represents and what we are trying to find, that is the height of the tree, we have that the height of the tree is approximately 25.1 meters.